Today, we're going to talk about the topic of function and piecewise function. Let us start our first subtopic, which is function. What is function? Function is a type of relation in which each x in domain is matched to one y in codomain. Here are some examples of function graph. The first one will be linear graph. The second will be quadratic graph. The next one is cubic graph. The last example will be reciprocal graph. Here is the example question for cubic graph. F is a cubic function given by fx equals to negative x minus 2 cubed. For question A, we are asked to find y-intercepts of the graph of f. We can assume that x equals to 0 to find the y-intercept, and hence the y-intercept for the function f will be 8. For question B, we need to find all zeros of f and their multiplicity. The zeros of f are solutions to negative x minus 2 cubed equals to 0. Function f has one zero at x equals to 2 of multiplicity 3, and therefore the graph of f cuts the x-axis at x equals to 2. Next, we are asked to find the domain and range of f. The domain of fx is the set of all real numbers. After expansion of fx, we can see that the leading coefficient of x cubed is negative. The graph of f is down on the right and up on the left, and hence the range of f is the set of all real numbers. For the last question, we need to use the y-intercept, x-intercept, and other properties of the graph to sketch the graph of f. Here is one of the exercise for cubic function. Do feel free to try it. The next subtopic we'll be talking about is piecewise function. What is piecewise function? Piecewise function is usually defined by more than one formula, a formula for each interval. Here is one of the example question for piecewise function. F is a function defined by fx equals to x squared plus 1 if x less than 2, while fx equals to negative x plus 3 if x more than and equals to 2. Now, let us find the domain and range of function f and graph it. The domain of f is the set of all real numbers since function f is defined for all real values of x. In the interval negative infinity until 2, the graph of f is a parabola shifted up 1 unit. Also, this interval is open at x equals to 2, and therefore the graph shows an open point on the graph at x equals to 2. In the interval 2 until positive infinity, the graph is a line with an x-intercept at 3 and 0, and passes through the point 2 and 1. The interval 2 until positive infinity is closed at x equals to 2, and the graph shows a close point. From the graph, we can observe that function f can take all real values. The range is given by negative infinity until positive infinity. Here is one of the exercise for piecewise function. You may challenge yourself by trying it. Lastly, we would like to thank both our calculus lecturers. Please kindly give us a big applause. That's all from our group. Thank you.